Border Gateway Protocol, BGP. See, from internet point of view, what we need to know. This is the only protocol that has got all necessary features that can be used between borders, between autonomous systems. Why? Because this has got flexible, rich metric called attributes. That's the big reason why we need these. So, what you can expect in interviews, can we manage with OSPF between the autonomous system? Is it recommended only BGP to be there between the autonomous system? For such question, answer is yes. BGP is the only one which is recommended. As a normal routing protocol, if you want to do routing with a normal plain routing, then a simple policy, then OSPF is okay. But between borders, we don't simply do normal routing. Why? You will have more than one ISP. Whenever you start a company today, in today's situation, you need to plan at least two service provider connection to talk to the internet, to talk to your WAN, means remote office. At least two, so that you will be always connected. Without communication, no business. Even for chutney, idli, and all, people depend on internet today. Then think about a company. You know, if you have two internet connection to a restaurant, then you will have non-stop customer flowing in, ordering things. Even for restaurant, you need redundant connection. See, again, I'm going like a class. You see, BGP has got attributes, rich metric, so BGP is the best. Using those attributes, we can have our policy requirements met in path selection. Policies that you have can be met in path selection using attributes. So what makes BGP a special protocol? The attributes, which is a flexible metric. If I ask you what is the metric of RIP, you will say hop count. Can you make RIP to understand bandwidth? So whenever you got redundant ISPs, definitely you will have policy. Your organization wants to use ISP1 as a primary, ISP2 as a backup, which is for high availability, for redundancy, which is called redundancy. So there will be definitely policy, you see. That is important. That ISP is a primary. That itself is a policy. When that fails, I want all the traffic to flow through the other ISP. See, what is this? This is policy. You can achieve this through OSPF, RAPE, floating static route. I'm not denying that, but not as easy as BGP. In BGP, to achieve these things, it's very easy than using OSPF or RAPE to achieve this. Fine. Let me just give you one small explain means the analogy to understand what I'm trying to say, and then we'll go. Using OSPF instead of BGP is like you take a Shift Desire to go to Canada. Of course, you can go to Canada with Shift Desire from India. I'm not denying that. People have gone from Bangalore to Canada in their Shift Desire. But is it that easy? Like what you used to enjoy in the flight? No. In flight, less than even if you go through a lot of connection flights, in less than 38 hours you will be there in Canada, in your home in Canada, in a hotel in Canada, which is not possible at all through Shift Desire. But you will go one day. That difference is what BGP and OSP. You can achieve through OSPF, but it will be a very tough way. Easily, BGP can allow the traffic flow according to the policy. OSPF will take lot of CPU. OSPF needs a lot of your tuning, brain work from your side. Different. Now, this is what I was talking about. You see, you have more than one ISP connected from the enterprises. We call it as multi-homing. Two reasons why people will go for multi-homing. One is the reliability. The other one is the preference. Performance. Reliability is provided by the active standby or active kind of reliability. Reliability, if one ISP goes down, still you got the connection via another ISP to internet. That is reliability. Performance, in what way performance? See, because you have two ISPs, you can use ISP as the gateway for few traffic. For all other traffic, you can use ISP-B as a gateway. In that way, you can improve the performance, kind of load sharing. So again, in this chapter, what is the most important? Okay, now every protocol guarantees a loop-free routing. Every protocol guarantees loop-free routing. BGP also. How? BGP uses the autonomous system number to guarantee a loop-free routing. See, this is again another question you may expect in interview. How loop is prevented? How loop is prevented in BGP? Yeah, accepted. Very nice. You already know this. Then BGP comes under a category called Path Vector Routing Protocol. Why is it? BGP advertises the AS path info, autonomous system number in the path, along with the prefixes. It not just advertises the prefix, along with each prefix, with each destination network info, it also advertises the AS numbers, the autonomous systems through which the updates come. So it shows the path and the direction of the path. That is why it is called as path vector routing protocol. Here, each autonomous system is considered as one hop. That's why it is path vector. Whereas RIP is a distance vector. Why? Because there each hop is one router. Each hop is one router. In RIP, each hop is one router. So if you have 5 hops, which means there are 5 routers to reach the destination. That is not the case in BGP. If you have 5 autonomous system in the path, it is only autonomous system. It's not number of routers. We do not know how many routers are in each autonomous system. So this is only the path, the autonomous system. This is between autonomous systems. This is internet protocol. BGP is an internet protocol. RIP is not an internet protocol. RIP is within organization. BGP is Australia to the place which is not yet discovered in the western side. To that level, BGP is spreading. BGP is the one determines the path in the internet between autonomous systems. So the main focus of BGP is to route the packet via the path as per the policy across the globe, not within the autonomous system. So BGP will not focus on number of routers because number of routers is not the matter here. When you have a protocol for the entire world, this is a single protocol for entire world. You cannot keep focusing on every small router. It focuses on autonomous system. One hop is an autonomous system, and BGP is a path vector routing protocol. Now, is BGP recommended if I have single hop? No. If I have single hop, means single what do I mean by hop here? Autonomous system. If I have only single autonomous system as my neighbor, whether you like or not, that's the only neighbor through which you need to reach the internet. So you won't have much policy there. Policy comes, yes, simple default route, static default route is enough. When we have only one ISP, you, there is no need for you to learn any internet routes, and there is no need for you to have any routing protocol. All that we need is a default route pointing towards ISP. But inside your organization, if you are having a server like a web, you have launched a web page in your server. We call it as web server. And if anyone wants to order something in your restaurant, they go to their website, and the website is actually in your hotel, in your restaurant, which means people from outside also need to talk to you. For that, you need a public IP address, and using the public IP address, you allow people to come in and access the web server. In that case, you need to advertise your public network to the internet people. Only then they can use the route in the routing table. So in that case, we will advertise some network. Otherwise, mostly we will do natting. We'll do natting so that our public addresses will not be inside our organization. It will be only in the edge. You can imagine, right, what I'm saying? Publics are only in the edge, and we do natting. So no need of advertising any private network. In that case, you need to simply have a default route towards your ISP, because your ISP only gave you the public address. ISP will bring all the packets that is sent by your customer to that address. What I'm trying to say here is, if it is single homed, if it is not multi homed, just go with simple protocol or static route or default route. Secondly, BGP, because it is having a lot of attributes, you should only use it when there is policy in path selection. If not, don't do that. Thirdly, if your autonomous system is a transit autonomous system, for example, your ISP is a transit autonomous system, they definitely need BGP. If they are transit, which means they are connected to more than one autonomous system. Now, if your router is very old, don't have much power, then if it is very important for you to have BGP, you have it. But have it like this. Don't learn all the routes of your ISP because your router is very small and old. It cannot accommodate that thousands of routes. So try to learn only few well-known destination routes, and for the rest, try to have default route, or try to totally avoid BGP by replacing some other protocol. Next is the BGP attribute knowledge. If you don't know attribute, how they work, how it can be manipulated to achieve your path selection based on the policy, then don't go for BGP. If you don't know attribute, don't do BGP. Yeah, I know only to enable BGP. No, that is not enough for you to say, I'll go for BGP. No, you cannot go for BGP if you simply know how to only enable it. Just enabling is not. We need to know how to use the attribute. Only then the protocol will be really productive. The processor, the RAM that you spent that you spend using BGP on router will be um, reasonable, acceptable only if you use the attributes effectively. All right. Now BGP uses 179 port number for identification, and BGP is a TCP based routing protocol. BGP, when you say TCP based, we should know that before any BGP packet between two routers, it will first, yes, it will first do three-way handshake. Only if there is successful SYN, and SYN with the forwarding acknowledgement, the BGP open message will be sent. If the three-way handshake is not possible, then BGP is not possible. Not only that, BGP don't send any periodic update. Whenever there's a change, the change will be sent instantly, triggered. BGP has got rich metrics, but we don't call it as metrics, we call it as attributes. As I said earlier, BGP is a protocol for the entire world, not for a single office, single company, single enterprises. It is designed to scale huge internet network. That is how it is designed. See, example, TCP. It is designed to scale huge internet network, meaning what? You don't need to flood and learn like you use multicasting to discover, nothing like that. We have to configure the neighbor manually. Only then the TCP three-way handshake can be established. This cannot discover neighbor because this is TCP based. Why it is TCP based? In order to scale the big internet. So only for those neighbors whom you configured under the router mode, the three-way handshake and the following BGP packets will be sent. Every router maintains BGP information in three different tables. Number one, neighbor table, which will have the established now configured neighbor. Neighbor table will have configured neighbor. See, in OSPF in EIGRP, neighbor table will have the neighbors which are well established, adjacency formed. But in BGP, okay, a lot of corrections in your statement. BGP, sorry, OSPF, EIGRP, they are not going to do broadcast. They'll use always this multicast to discover neighbor. Yeah, that was one problem in your statement. Secondly, uh, BGP is not advertising anything here. Nothing based on the advertisement. BGP by using TCP 179, it's an application layer protocol. BGP is an application layer protocol. It talks to the other router like an application. It says, "Hey, my friend, I am willing to have a session with you using 179 port number. That's the application number, 179 BGP. What do you say?" And if the other router is also configured, then it is going to accept. That is how the neighbor get established. So it is not advertisement. Neighbors are not learned through advertisement. Neighbors are learned based on the successful three-way handshake followed by BGP's negotiation packet. So we should not use the word advertisement. There's no advertisement. Even in OSPF and EAGRP, you should not use advertisement. Neighbors are learned using hello packets in OSPF and EIGRP. When the hello packet comes, in the hello packet, it knows from where it is coming, from whom it is coming. That's how it learns. It's not an advertisement. You should not say it is an advertisement. Okay, coming back to this story here, in BGP, if you configure neighbor, immediately it will be there in the neighbor table, even when the neighbor is still not up, even when the neighborship is not active. It will show you the state. What is the current state? Current state may be disconnected or down state, something like that. So a neighbor table will have list of neighbors, and it will also show you the status between the neighbors. Is it established or somewhere in the middle? Now there is another interesting table where we usually go and check whether we are learning, whether we are advertising, in a table called forwarding database, BGP table. Simple command to see this. Show IPBGP. That's all. Show IPBGP. That's it. It will show you the networks that this router advertises and the networks that are learned from the other neighbors, along with attributes. That's the important thing. It will show very clearly all the attributes that are attached to each destination. And if you have multiple paths, it will show you all those paths, and it will also show you which path is considered among the multiple paths. In the routing table, you will have only the considered, elected best path. Now, there are 5 different type of message types we have in BGP. One is open message, which is sent right immediately after the successful three-way handshake. open message. This goes along with the router ID and the hold time. And the open message will go with the router ID, which should be, no, sorry, which need not to be a reachable address. That the router ID is simply an identification, same like OSP. That router ID is simply an ID. It need not to be a pingable address from the neighbor. For example, if router's router ID is 1.1.1.1, when router 2 learns it, there is no need for router 2 to ping that address. It's just an ID. And the hold time is 180 seconds. Same like it. Anyway, what I want to say here is the keep alives are sent every 60 seconds, which is another message type. If a keep alive is not coming after 180 seconds, which is the whole time, if keep alive is not coming from a neighbor for 180 seconds, the neighbor is going to be removed. Update packets will have the network and the attribute informations which are sent between the routers. Notification is also a kind of update. No. See, updates or information for one part only, meaning you are in a place called X and to reach Z, you can go via Y, you can also go via W. Let's say your X have chosen W as the path, but you also have Y information in the BGP table, but in the routing table, you have only W because that is the elected one. Now, when X sends an update about the Z network, it won't talk about Y to V route. V router will only get this as an update, not this. Because in the routing table, you have only W path. Notification is like when this W path somewhere gets some problem, immediately it will be notified to X and X will look into the BGP table and it will make this as the elected path and that will be immediately sent as an update. For this X router, it is a notification. For V router, it is an update. So notification is only when you have error in the path which is already in use. All right, so um, see this BGP has got two different approach depending on the environment, two different flavors, two different approach informing neighbor in distributing the routes. That is what I want to make it clear here. BGP has got um, a, f- um, a flexible route distribution within the autonomous system. We call that as IBGP. And between the EBGP, it is not that flexible. It is very strict because it is between different autonomous system. When it is between different autonomous system, it cannot be very flexible. It needs to be strict, and we call that as EBGP relationship. Yeah. So EBGP, why it need to be strict? Why IBGP need to be liberal? You know the reason. Between autonomous system, we have policy. Within autonomous system, we are a little bit uh, flexible. Now, this is one important place. There is a problem in BGP called IBGP split horizon issue. That's not a problem. That is uh, security. There's a security within BGP to avoid loop. It's a loop prevention mechanism within the autonomous system. You see, when I was talking about loop prevention, you said autonomous system number is used to prevent loop. I'm not denying that. Yes, it is true, correct. But that is an EBGP answer. But when I enable BGP on all the routers like this, when I enable BGP on all the routers like this within the autonomous system, then here what is going to prevent loop? The loop, see, they all belong to same autonomous system. So there should be some loop prevention mechanism within the autonomous system in an IBGP scenario. That is what called as IBGP split horizon rule. This is what the IBGP split horizon rule. What does the rule says? The rule says that the route that you learn from one IBGP, you should never propagate to other IBGP peer. Simple. This avoids loop. Listen carefully. If I have a switch in the middle and when I don't have this rule, see what will happen. When I don't have this rule, an update is sent, it goes to everyone, and they think that the other neighbors have not received it. So this guy called A, he's sending again a copy to these two guys. At the same point of time, this guy thinks that A and B don't know, so he's also sending the same update. Likewise, B also sends, and then the update that is received from A, B thinks that this K don't know, so it is sending to K and C. So same copy of update which was earlier sent by K is now duplicated multiple times and sent again to all of them. This causes loop and it will make the total traffic jam in the network. It's very serious. To avoid that, see again same diagram I'm drawing. An update is coming. That update is learned by A, B, and C. Now A, B, and C are not allowed to propagate to other IBGP. If you have a EBGP, it can propagate. It can propagate to EBGP, but it is not supposed to send to IBGP. So A will never send this to B and C. That prevents loop. Did you understand this? Okay. So why do we have this IBGP split horizon rule to prevent loop? What is that rule says? You are not supposed to propagate the route that you learn from one IBGP to another IBGP. Okay. Yeah, that is what IBGP. Yeah. So that is the actual good reason. And is it good? Yes, it is very, very good. But in this type of topology, this one, and this one, and all these are same topology only, four router. In this topology, this rule is one big headache. This rule is one headache. What? You see, there is no physical connection here. Physically, they are connected like this, only like this. So when an update comes, B will send to D, also to C, but D and C won't send it to E, isn't it? Because the rule says never propagate. Likewise, when F sends an update, E will send to D and C, and D and C will never send it to B. If B don't receive, then how A will receive? They won't receive. So you will never have a reachability between A and F because of this rule. To override this, what we are going to do. So what do we do for this scenario? There are many solutions. One solution is we used to have MP-BGP tunnel, a tunnel between this router, so that you no need to even enable BGP on this router. But now we are not focusing on MPLS. What is the other reason, other solution? One of the solution is shown here, making full mesh, meaning in B, you tell DC as a neighbor, that is what this diagram. What is the difference between this diagram and this diagram? You also say E as a neighbor. You see this line here. This arrow mark means neighborship. In it, not need to be physically, there is no physical connection here. So you form IBGP neighborship with every router, even when the routers are not directly connected. Because it's a TCP based protocol, it can easily form neighbor. As long as the reachability is there, they can form neighbor. And when you do that, BGP will directly give an update to E. The other way is you can reflect the route. We call it as route reflector. If you don't want to make full mesh, you can go and override this rule by saying to go to D and say it is okay, distribute it to E. Route reflector client E. You use the key command route reflector client and give the IP address of E. So that the route that was coming from B to D will be forwarded to E. Okay, that is route reflector. Route reflector, why do we need route reflector? You should answer this in the interview if they ask this question. Why do we need route reflector? Route reflector is to override the IBGP split horizon issue. What is IBGP split horizon issue? In order to avoid loop within the same autonomous system IBGP peers, route learned from one IBGP are never allowed to propagate to other IBGP. In a LAN environment, that solves the problem. But when you connect the routers like this in a serial way, B connecting to D and D connecting to E and E connecting to C and C connecting back to B, when there is no physical connection between B and E and also between C and D, you need to have either route reflector or full mesh to solve the problem. All right. So that issue is explained in this picture, and then the solution is here. Right. So during the configuration, you have to do some consideration when you have some special uh, neighborship. For example, see this topology here. Here, forming neighborship using loopback interface address is the recommended one. Why? Even if one path goes down, you can reach the loopback via the other path. That is why. Forming neighborship using loopback is recommended. When I form neighbor with the physical interface, then redundancy won't be there. If, for example, on router A, if I say this as the neighbor, if the path goes bad, then I lose the neighbor. If I would have formed neighbor using this loopback, even if this goes bad, no problem. 4 is reachable via this way. So neighbor will still continue to be there when you use loopback. But when you use loopback, you need to consider and you need to put some special command. What is that? Usually BGP will use the exit interface address as the neighbor address. But on router D, you have made 1.1.1.1 as neighbor. Router A, you have configured 4.4.4.4 as a neighbor. According to router D, the neighbor is 1.1.1.1, but the packet is coming from 10.1.1.1, which won't be accepted. So what you have to do is you have to tell router A not to use this address, but to use this address, so that when you talk with this address, it will match with the neighbor list in D and neighbor get established. That's what written. That is what written in here. If match is found, only then the relationship will be established. If match is not found, the packet will be ignored. So make sure the source address matches with the neighbor address in the neighbor statement of the neighbor router, which I just said. You have to source it from your loop. For that, the command is update source. We use update source. So this is one command which may not be clear for many. They may test you. Why do we need update source? When do we need update source? Whenever we are forming neighbor using loopback, we need to use update source. If not, the exit interface will be the source address, which won't match with the neighbor's neighbor statement. In order to make it match, you need to use the update source command. Next, when do we use EBGP multi-hop command? EBGP neighbors, the neighbor address that you mentioned, need to be a directly connected address of the subnet of the address. For example, in router A, if I say this address as the neighbor address, it is directly connected. Neighborship will come. But when you form neighbor using loopback, we need to provide reachability. So you write static route and you also say update source, which we just learned. But that is not enough. Why? By default, EBGP expects neighbor to be one hop away, meaning directly connected. Even though this, what? Let me continue. You see, by default, the neighbor need to be directly connected. To achieve that, BGP is designed to send the packet with one TTL. But now your neighbor is not directly connected. Even though it is one hop away, it is behind that one hop. It is not two hop, it is still one hop, but it is behind the one hop. When you put two, you break this rule. What rule? You are saying my neighbor can be even behind. When you say TTL 2, outgoing TTL, that is what this command will do. By default, the outgoing TTL is 1. By putting this EBGP multi-hop 2 command, you make it as 2, which means you are indirectly telling The neighbor need not to be directly connected. He can be anywhere in less than 2 hop. Yeah, that is the use of this command ebgp multi-hop. Next is the next hop behavior. Listen to this carefully. This 172.16 network, which B is giving to C, which was learned from A initially advertised this, B is forwarding it to C. When it forwards to C, B will not put its own ID. B will use the router ID of the other autonomous system. B will use the address of the EBGP neighbor. B will not put its own address. B will keep the address that is coming from the neighboring autonomous system number, neighbor autonomous system. So, neighbor autonomous system given address is maintained. It is carried to C. But C don't have reachability to the neighbor autonomous system. C don't have. Is there any connection? No. No. C don't have reachability. So what will happen is C cannot use that route because C is learning next hop 10.10.10.3, which is unreachable for C. To reach this network, the next hop is 10.10.10.3, which is unreachable for C. So C will say it is valid, but it is not best. So what I have to do is I have to tell B not to carry this address, instead advertise its own by saying next hop self. You see here, advertisement is coming from here, 10.10.10.0.0.0 is coming from A. Usually B will advertise this address to C. But when you say next hop self, you are telling B whenever you speak to 3333, put your own address as the next hop. So router B is putting its own address so that C will have a reachable next hop. Did you understand this? So three things we have seen in this chapter. One is EBGP multi-hop command. Another one is update source command. Another one is next hop self command. Right? And this is one unique behavior of BGP. You will not believe it. That type of scenario it is. Let's see what it is. Same in the next hop behavior only. This is coming. Listen carefully, closely, watch. This network is advertised by C and B learns it. What relationship they have? IBGP. Is there a EBGP relationship between C and A? Answer, please. Is there an EBGP relationship between C and A? What? How you say yes? Where is it? Where it is mentioned? EBGP is between only B and A. Now, you see, C and A don't have neighborship. Now, C is advertising this network to B. B is advertising to A because only B and A has got neighborship. But, 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 but A learns that in order to reach 172.30.0.0, the best entry point is 10, 10, 10, 2. But who gave you this update? Who gave A the update? It is not C. B only gives the update. But B says, listen, me, you, and the giver of this network, we are all the same subnet. So the original giver is in the same LAN as you and me are. So you no need to come through me always. It's going to be a long route for you. You can just go to 10, 10 to directly. BGP is being an efficient by informing 64520 of best entry point to 6500 for the network. As this one. This as the next one. Not 10, 10, 10, 1. Please take a minute, go through this yourself, read it, compare the understanding with the picture here, and see whether you got what I explained. If not, let me know. I'll repeat. Peer group is a template when you have common outbound configuration to do, outbound related configuration. You can put them in peer group and call the peer group. Advantages in single go, in single processing, it gets processed, and line of code also decreases. Next is network. If you want to advertise, you use the keyword network. To form neighbor, we use the keyword neighbor. Network and then tell the network. In case if it is subnetted, you need to use the mask command and mention the subnet mask. The subnet mask that you mentioned should match with the mask that is there in the routing table. Yeah, like this. See, if you have summarized like supernetting, you can even put mask like this. Make sure you have done that supernet. It means you have summarized it to /16. By default, it is /24. By default itself is 24, but you have done supernetting. Means you have done less than the default. If you have already summarized, then the route will be there in the routing table with /16 for 192.168. You can mention that like this in the BGP advertisement. This is an old consideration. It's no more needed, but I'll quickly explain and go. What is synchronization? You see, do not use, do not advertise to any external neighbor the route learned from IBGP until the same route has been learned via IGP. For example, you see here, this network, F is advertising to B, B is advertising to D, C, and A. Now, A is not allowed. A should not advertise to E. You see, whatever you learn from IBGP, you should not use, you should not advertise. So A will not, D will not use it, C will not use it, A will neither use it nor advertise it to EBGP. When will A advertise? If IGP, sorry, if OSPF or something in this autonomous system also, OSPF also advertises the same network, which is stupidity. That's why they have cancelled it. You see, that was some stupid law. So they have offed it from 12.2 and later version. So don't worry about this. But for knowledge, you should know what is BGP synchronization rule. It's a waste rule which was there called synchronization rule, which says that you should not use or advertise the route learned from an IBGP to EBGP until the same route is being advertised and learned via IGP protocol like OSPF. Initially, they thought that is more secure. Later, they understood no, it is not security, it is also denial of service. So they lifted it up. All right. So next is BGP states. See, while establishing neighbor, as I told you earlier, after three-way handshake, they try to establish for that it will send an open message. During that time, it will be in idle state, meaning it is checking the routing table and see whether I have the route to reach my neighbor. In that period, it is idle state. And when the route is found, it uses the route and send the open message. Before sending the open message, when the route is found, it is sending the sync packet and waits for the three-way handshake to get established. That is connect state. After the connect state, it sends the real open message, the first packet with the router ID and the hold time 180 seconds, which is called open send. When the neighbor accepts the open send packet, then neighbor should reply by confirming open confirm, and then it goes to established state. Sometime you will see it gets stuck in idle state, which means there is no route in the routing table. By typing this command show IP BGP neighbor, you will see whether the neighbor is established or not. If it's stuck in active, if you see show IP BGP summary command with active state, which means that the address that you mentioned as a neighbor address may be wrong, or the update source you might have failed to give, so it is sourcing with the wrong address, or the neighbor statement itself is not configured, or the autonomous system may be misconfigured. Fix this, then it will come normal. Whenever we have autonomous system number misconfigured, you will get this type of Fs, and you will also see logs. You don't need to enable any debug to get this. Without you enabling debug in iOS, it will show you this. Go and change the correct autonomous system, then it will form neighbor. All right, so this is how we configure neighbor, sample configuration. What is rib failure? You learned route through BGP, but OSPF also gave the same route with a lesser administrative distance. Routing table will use the one which gives route with less administrative distance. So those networks which are those routes that are given by BGP that are not used by the router will have rib failure. Routing information base failure. Uh, by by hearing the word failure, you should not think that oh something dangerous. No, 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 no. It is like this. Your friend gave you, your brother gave you. You prefer your brother and you ignore your friend. It doesn't mean that the friendship is gone. No, no, no. Anyone you should take, two air tickets. One your friend is giving, another your brother is giving. So you take your brother's air ticket, brother given air ticket. You ignore your friend saying, no, thank you, I already received from my brother. Likewise, when OSPF and IBGP gives, IBGP administrative distance is 200, OSPF is only 110. So OSPF given route for these networks are taken by the routing table. So BGP says, even though I gave, because of my high administrative distance, it is not in use. That's the meaning of a RIB failure. For all the RIB failure, you will have R here. This is RIB failure. Meaning BGP is giving valid route, no doubt, but unfortunately, there is another protocol giving with small administrative distance. Whenever you do some changes to the policy, you have to do soft reset at least. Do soft reset by saying clear IPBGP star soft, or you can also mention a particular neighbor. To refresh the route, you can do that. If you don't put soft, then it is going to be hard reset. It will discard all the neighbor and re-establish. All right. So that brings us to the end of this chapter.